System buses, data, address, control. Intermediate level introduction. Inside a computer, different components like the CPU, RAM, storage, and peripherals must constantly communicate. This communication happens through system buses, which act like highways carrying information across the system. There are three main types of system buses. Data bus means carries actual data. Address bus means carries memory addresses. Control bus means carries control signals. At the intermediate level, understanding system buses means learning how data moves inside a computer, how CPU communicates with memory, how instructions are executed, how system performance depends on bus design. What is a system bus? A system bus is a collection of communication pathways that connect major components of a computer. In simple terms, system bus equals communication system between CPU, memory, and devices. Example concept: CPU, system bus, RAM I/O devices. Types of system buses. The system bus consists of three main parts: data bus, address bus, control bus. Example concept: system bus equals data plus address plus control. Data bus. What is data bus? The data bus carries the actual data between components. Function transfers data between CPU and RAM, carries instructions and results, moves data to and from I/O devices. Example concept: RAM means data bus means CPU characteristics. Bidirectional, data moves both ways. Width determines how much data is transferred at once. Example: 8-bit bus means 8 bits per transfer. 64-bit bus means 64 bits per transfer. The address bus carries the location address of data in memory. Function tells where data should be read or written, used by CPU to access specific memory locations. Example concept: CPU means address bus means memory location. Characteristics: unidirectional. CPU means memory. Width determines maximum memory capacity. Example: 32-bit address bus means can address 4 gigabytes memory. 64-bit address bus means supports very large memory. Control bus. What is control bus? The control bus carries control signals that coordinate operations. Function signals read-write operations, controls timing, manages interrupts, synchronizes components. Example concept: control signals means manage data transfer. Examples of signals: read signal, write signal, interrupt signal, clock signal. All three buses work together during data transfer. CPU request means address bus, means control bus, means data bus, CPU. Request means address bus, means control bus, means data bus. Step-by-step process: CPU sends address via address bus, control bus sends read-write signal, data bus transfers actual data. Real-world example: reading data from memory. CPU requests data. Address sent via address bus. Control bus sends read signal. Data returned via data bus. CPU processes data. Bus width and performance bus width. Number of bits transferred at once. Impact: higher bus width means more data per transfer, means better performance. Higher bus width means more data per transfer, means better performance. Example: 32-bit bus means slower. 64-bit bus means faster bus speed. Bus speed determines how fast data travels. Example concept: higher speed means faster communication, bottlenecks in bus system. If buses are slow or overloaded, CPU waits for data system performance drops. Example concept: slow bus means data delay, means bottleneck, modern improvements. Modern systems use advanced bus technologies. PCIe, high-speed expansion bus. Memory buses, optimized for RAM-integrated controllers in CPU. Example concept: modern buses means faster and more efficient communication. Advantages of system buses. Advantages include structured communication, efficient data transfer coordination between components, scalability. Example concept: well-designed buses mean smooth system operation. Limitations. Challenges include limited bandwidth congestion with multiple devices latency issues. Example concept: too much data means bus congestion. concepts learned. Check what system bus is. Check roles of data, address, and control buses. How data flows inside a computer. Check how bus width affects performance. Check how buses coordinate system operations. Simple definition. System buses. Data, address, control. Communication pathways that transfer data, memory addresses, and control signals between CPU, memory, and devices. Final summary. System buses are essential for communication inside a computer. The data bus carries actual data. The address bus specifies memory locations, and the control bus coordinates operations. Together, they enable the CPU, memory, and devices to work as a unified system. Understanding system buses is fundamental to learning computer architecture, system design, and performance optimization.